So student, now in this lecture, we are going to focus for the structure of covalent molecules. Okay, so to explain the structure of covalent molecule, there are two theories that we are going to see one by one. But here, the what is how the structure of covalent molecule is explained, and then the in which means what nomenclature is there for the study of structure of molecule, or what branch of chemistry we can call it. Here, the stereochemistry. That is stereochemistry, okay? And that word you have heard, the stereochemistry in the 12th standard only. So the branch of science which deals with the problem concerned with the spatial arrangement of atom in a molecule, ion, and other species in crystal is known as stereochemistry. Okay, is known as stereochemistry. Or I can say in easy word, the branch of science which deals with the three-dimensional study of any molecule is called as a stereochemistry. Okay, so this chemistry, the word stereochemistry was born in 1874, and that was coined by Van 't Hoff and Liebel. Okay, so they put forth some postulates of tetrahedral arrangement of the valences of saturated carbon atom, and then this word came into existence. So right now, we shall discuss the two theories with the help of which we can understand shape of inorganic molecules. Okay, so here in this lecture, we are going to focus for Sedgwick-Powell theory, and in the next lecture we'll proceed towards the valence shell electron pair repulsion theory. Okay, if possible, I will continue for the second theory also, but we'll see how it seems to be for understanding purpose in the whole lecture. Okay, so first is the Sedgwick-Powell theory and the shape of molecule. So in 1940, N.V. Sedgwick and H.E. Powell reviewed the structure of molecules. Okay, and they found some new things over there, and then they explained that the basic factor in deciding the spatial distribution, म्हणजे space मध्ये, okay, three-dimensional म्हणूयात, the spatial distribution of bond around the central atom was total number of electron in it, or in its valence shell, that is the valence shell electron, and the electrons are gained by that atom from the other atom with which it forms the covalent bond. म्हणजे CH4 मॉलिक्यूल मध्ये कार्बनचे व्हॅलेन्स शेल इलेक्ट्रॉन किती आहेत आणि त्याने हायड्रोजन कडून किती इलेक्ट्रॉन घेतलेले आहेत, that is going to decide the structure of CH4 molecule. In this way, they are talking over here. Okay, in simple manner. Pair of electron in valence shell adopt that arrangement which maximizes their distance apart. Okay, that is the electron pair behave as if they repel each other, or you can say that the atom or the bonded atom to the central atom are trying to stay as much apart as possible from each other. ते जे सी कार्बन जो आहे त्याला जे 4 हायड्रोजन ॲटम अटॅच आहे, ते 4 हायड्रोजन एकमेकांपासून जेवढं दूर शक्य आहे है ना, तेवढं दूर राहण्याचा प्रयत्न करतात. In a simple word, you can say, right? Now, the following are some assumptions that are implicit in the above mentioned rule. Which assumptions are there? Okay, the inner shell of central atom are complete, and therefore it's a central core consisting of nucleus, and the completed inner shell is a spherical. Thus, the spherical central core will not have any effect on distribution of outer or valence shell electron or valence electron. Okay, this is what the first assumption. Okay, this is assumption, not the fact. So that time they explain as assumption. So in a non-transitional element, okay, So shape of a central core is not a spherical, and that's why over here we are going to focus those atoms, okay, or those the molecule which contain non-transitional elements. Okay, now the electron pair in the valence shell are all at the same average distance from the nucleus. Electrons pair in the valence shell are all at the same average distance from the nucleus. ज्या इलेक्ट्रॉन पेअर आहेत त्या न्यूक्लियस पासून सेम डिस्टन्स असतात. The bond pair of electron and the lone pair of electron are considered as equivalent in this theory, but in B.Sc.P.R. the scene will be the different. The regular geometrical shape of molecule are expected only when all electron pair are used in the bonding to identical atom, as in CH4. Okay. What happens? The regular geometrical shape is obtained only when all atoms which are attached to the central atom are identical. इथे 4 हायड्रोजन आयटम अटॅच आहे कार्बनला, म्हणून तो काय आहे की आपण काय म्हणूया त्याची जिओमेट्रिकल रेग्युलर असते. ओके, बट इफ द डिफरंट आयटम्स आर अटॅच्ड to a central atom, then that shows a distortion in the geometry. So what they are doing here now, they are finding to understand this, to understand the structure, they are trying to find out the number of electron around the central atom, okay, or in the valence shell of central atom. Valence shell of central atom plus electron contributed by the surrounding atom upon 2. Now see, if you consider the beryllium atom, so electronic configuration of beryllium is 1s to 2s2. So 2 electrons are there in the outer shell, valence shell. And it takes 2 electrons from the chlorine atom. So total 4 electrons are there, right? Here you can see 1 electron is from chlorine, right? And 1 electron from this chlorine. It has its own 2 electrons, right? So total 4 electrons are there, these 2 and these 2. So 4 upon 2 here. The answer is 2. Okay, and according to this theory, the beryllium shows a planar structure or linear structure. Okay, the bond angle is 180 over here. Now they consider one more structure of boron trifluoride. Okay, over where the boron have 3 electron in the outermost shell, and it takes the 3 electron from 3 fluorine atom. Total becomes 6. 6 upon 2, that is 3. So what they said, that the structure is planar triangular. The structure is planar triangular. It's a predicted structure. Okay, predicted structure. The bond angle is 120. One more thing is there. See, now methane molecule is there. Then silicon tetrachloride is there. Ammonia is there. Water molecule is there. Okay, so for this they are considering same thing, and they found that these molecules are having tetrahedral structure. These molecules are having tetrahedral, okay, where the bond angle is 109 degree and 28 minutes. 109 degree and 28 minutes. Okay, so after that valence shell electron pair repulsion theory is there, but I think for this lecture it's enough, so that you will not get confused at a time by focusing for the two theories. It will create a kind of confusion to you. So better to first learn this theory and then only proceed to the next theory. Okay, if any confusion is there, please contact me.